Okay, so our next speaker is Erik Brenneis from IoT, who's the IoT director at Vodafone Business. And he's going to answer the question, we hope, of who's putting the AI in IoT. Thank you very much.
Okay.
Yeah.
Very good. Well, very nice to meet all of you, and I'm happy to talk about AI and IoT, which are really two boom areas at the moment. Before we jump into how AI and IoT come together, I just want to quickly show you a few numbers about IoT, which actually prove that this is not an early market anymore. It's actually gone into almost being a mature market, and you will also see later a few statistics which show that it's very important for our customers, and actually everybody is doing IoT. From a numbers point of view, we alone, for example, have more than 100 million connections, IoT connections at this moment, 123 million. And even throughout the pandemic, this number of connections has grown by more than 20%. So the momentum is there. We have 182 countries to which we deliver IoT services, 570 networks, and also the new networks, the low power wide area networks with the so-called narrowband IoT standard, which is very good for devices which have a long battery life and don't send that much data. They are also rolled out at this moment. So very big momentum on IoT. Let's have a look on the next slide at what actually businesses think about IoT. Is somebody operating the slides? Next slide, please. Okay, so businesses actually, well, let's start with the pandemic. Now, as horrible as Corona has been for the world and still is, the benefits on the IoT business and digital businesses in general have been over the last year, obviously, that everybody has built their digital infrastructure, and actually all the companies have come to realize that IoT is really critical for their business. We conduct a survey with more than 1,000 customers every year, where we ask them, how important is IoT for you? Where do you see issues? What's the payback for you? And actually 87% of all customers, and these are not only IoT users, this is across all industries, they say that IoT is absolutely critical to the future success. 73% say that companies who don't adopt IoT will actually fall behind. And 77% say that IoT provides them with greater adaptability and resilience in their business. And that's the reason why a lot more IoT projects have been started this past year, developments, than ever before. Let's have a look at the next slide. Basically, without IoT, there's no really meaningful artificial intelligence for most markets. Why? Imagine it's like a human being, right? If you only have a brain, but you don't have an eye which can see, you don't have a nose that can smell, you don't have hands that can feel, then you don't have any data about what's going on around yourself. And that is actually how AI, artificial intelligence, and IoT come together. IoT is needed to acquire the data from all kinds of sensors, from devices such as cars, electricity meters, and so on. But somebody needs to make sense of this data, and that's what AI is doing in the cloud or somewhere else by doing the right processing on all this data and coming to meaningful insights and then acting on these insights. Next slide, please. So it's very clear that artificial and IoT coexist and absolutely need each other in order to do advanced analytics on IoT data. For example, the maker or the producer of a production machine needs to get data from that machine in order to see how it performs and in order to repair it remotely if it has a problem. Data visualization is something which artificial intelligence does with IoT data. And in order for machines to learn, they need more and more data. They need to understand whether what they predicted actually turned out in reality. So there needs to be a loop back from the data acquisition again into the artificial intelligence. And this is how things come together. Now, if you just acquire data without having the intelligence, it doesn't help much, but the intelligence without data doesn't do anything either. And it becomes really powerful when you can actually connect different data points, which previously, before IoT and artificial intelligence, were actually not connected, or people weren't able to make connections between these. For example, if you measure the level of pollution within a certain city, that tells you problems, but it could actually be the traffic, could also be other things like a factory or the wind blowing pollution there. Only if you connect that data with actually the data that you get from traffic flows, you can immediately get the function between the traffic and the air quality in a certain area. And that's the power of artificial intelligence and IoT combined, that you can actually get to insights which otherwise you wouldn't have. Let's have a look at the next slide, please. On this one, we actually see 3 areas which IoT are driving at the moment. And like I said before, all companies are trying to accelerate their digital agenda. So on the left-hand side, what we call a digital thread, those are actually all the companies which have, for example, complex processes. That can be a manufacturing site, or it can be a refinery, and they need data like pressure, data about pressure, data about certain levels of oil, data about temperature, and so on and so forth. This data is acquired through IoT and is processed through artificial intelligence. And then if there's a problem, you detect it early, you act fast. And this data is also used to continuously improve the process, save fuel, for example, increase safety, and so on and so forth. That's actually the classical IoT use case, that customers use IoT in order to understand their processes better, to manage them in real time, and to also improve their processes. Now, a digital twin is actually a simulation of a real thing in the digital world. Why is something like this useful? Because if you have such a simulation of a real thing in a digital world, you can actually feed it with certain data, also with real data that you acquire from the real thing, and you can predict how something behaves. You can anticipate problems, failures, act against that, and also use that in product development to make better products. One such example is, for example, the turbine in a power station. You can have nowadays a digital twin of this turbine, where digitally you can say, okay, if you run it at this and this speed and at this and this temperature for this much time, the likelihood of it failing is this much. And the signs, for example, that it will soon fail is an increase in temperature by so and so much %. And then you can measure the real thing, which is deployed in the power stations. And if, for example, one of the critical parameters in reality goes above a certain threshold, you can run a simulation on your digital twin and act and prevent issues, and also use that during for the product development, so that these systems become even more resilient in the future. And IoT also helps nowadays a lot more, especially with 5G. I'll get to 5G, on virtual reality and data analytics. An example there is, for example, is that we have a partnership with a medical company called Proximi, and they actually equip surgeons, great specialists, with virtual reality and augmented reality systems. And then they measure real parameters at the site where an operation is happening, which can be on the other side of the world. And the specialist, the surgeon, is actually there managing things. And the people in the operating room can then act on his or her advice. So very useful and revolutionary, which is already happening today. Next slide, please. Let's talk about 5G for a moment. So for most people, especially consumers, 5G just means faster data. It's even faster than 4G, right? But let's be honest, 4G, with a good 4G network, watching video is not that big of a problem. So with regards to bandwidth, applications such as full virtual reality applications, where you can walk around, be mobile, that's where you need 5G. Also augmented reality, where you wear glasses, for example, if you're a maintenance specialist, and then you look at a complex thing, like for example an aircraft engine, and it tells you exactly what this means and that. These things are supported by 5G, which you can't really do today. With 5G, low latency is something which is very important and useful. So the latency is the time it takes between the moment when you send a message and when it arrives at its destination. Today, we have roughly about 30 milliseconds in a 4G network. In a 5G network, this can go down to 1 millisecond, and that is actually much, much faster than human reaction time, which is about 20 milliseconds. So with a 5G network, one car notifying another car that it's braking now is much faster than a human person which pays attention. So there you can really make traffic safer in autonomous driving, for example. And quality of service in 5G, you can dedicate a certain slice of the network to a certain use case, which makes it a deterministic system. Therefore, we can also use it for applications such as monitoring of a power grid, which needs to have absolute certainty and reliability, which today is all connected only through fixed lines. So the combination of all this makes a lot of applications possible, real-time applications, very critical applications, which previously haven't been possible. So we expect a lot more momentum there. Next slide, please. We are also building, and the industry is also building, dedicated 5G networks for customers. We have a 5G private network with Ford for their production site in the UK, for example, where autonomous vehicles in the factory and process automation, factory automation, acquisition of data from certain sensors is attached to it. But the really cool thing about this network is that the Ford factory is directly connected to the Welding Institute in Cambridge, which has the same 5G network. So they're in real time connected. So when something happens in the factory, which is connected to welding, the experts in the Cambridge Institute can immediately deal with it, suggest a solution in real time, and that makes things so much faster, and the downtime or the potential downtime of machines goes to zero, which means that the customer can actually be sure to not have any downtimes, which is very costly. Next slide. My final example is one for augmented reality. So with Vodafone UK, we use augmented reality for our service technicians out in the field, which have glasses on them, which when they look at telecom equipment, which leads them directly through what to do with that, what it is, and this system is also connected to the IoT measurement of this equipment. So the technician will get a message immediately if something is broken, and will see the problem so that they can immediately resolve that. That's a good example of where virtual reality, augmented reality, and artificial intelligence come together with IoT to create a really big benefit and ensure that we have less outages and can identify faulty equipment immediately and replace it. So basically, with all these examples, I just wanted to give a quick overview across what's happening, which role 5G will play, and how artificial intelligence and IoT have already come together. And I'd like to open up for some questions now.
Thank you, Erik. So one of our attendees asks, if the latency reduction from 4G to 5G is only one order of magnitude, as we know it today, do you think it'll be enough, given the amount of data to drive real-time decisions in the AI-backed world? So is one order of magnitude decrease in latency enough to make a really big difference?
I think the latency difference between 4G and 5G is exactly the difference between the ability to operate a real-time system and something not being suitable for real-time and critical application. I gave the example about autonomous driving before. So with a latency of 30 milliseconds, just sending the message alone from one car to the other is longer than human reaction time, right? So an autonomous car brakes slower than a human being. With 1 millisecond, and by the way, combining that with multi-edge computing, where mobile edge computing, where actually the application runs very close to the location and is not in a cloud somewhere, maybe on the other side of the Atlantic or far away, then you really achieve numbers that a car responds within 5 milliseconds or something, which is much, much faster than the human reaction time. Also, with 5G, it is possible to monitor an electricity grid network. With 4G, it's not possible to do that because the difference in latency is exactly what makes the difference.
Okay, Erik, and we've just got time to sneak one more question in, please. This questioner says that they agree with you about the relative maturity of current AI applications and suggest the future is about cross-silo data sharing and explainable AI. So what do mobile network operators, which are incentivized by the number of SIMs, what do they need to do to capture a share in these emerging market segments?
I think we need to do a few things in parallel. One is obviously we need to ensure that our networks perform exactly at the level which we were talking about, and that we can actually transmit the data reliably and in the short time frames that we explained through a combination of network technology, 5G, and also design of the application with mobile edge cloud computing, where time is of essence, and so on. Secondly, I think that's exactly right. Different silos, which are today not connected, come together. So therefore, the data exchange between these systems, or actually rather into a system on top of vertical systems, needs to be there, and operators can actually help bringing these vertical markets together, because we provide connectivity for all these markets, and we also provide individual solutions in some of these markets. And it's about cooperation with other players, with the cloud players, for example, which we are all doing, and also with vertical specialists, so that these vertical solutions, whether it's for manufacturing or energy or automotive, are actually able to be opened up and share the data.
Thank you. That was a good, comprehensive answer. And thank you, Erik, for a really interesting presentation as ever.